So in 7.3, learning logarithms, key things that you need to know. Okay? Key things you need to know. And actually the first thing that I want to tell you before we get anywhere farther in this section is, and you're going to want to write this down, a log is an exponent. A log is an exponent. Okay? That's one of those phrases that will help you remember where to go if you just have a brain fart. Okay? We've all had those times where you forget how to spell the word to or the. You know, it's one of those things like, okay, that's super simple. Why don't I remember how to do this? Okay? Well, this is kind of that phrase that puts you back on track. If you're working a problem dealing with logarithms and you just are totally lost on what to do, remember this phrase. Okay? A log is an exponent. Because, first off, because it's right. All right? Because that's exactly what it is. But the second thing is I'll show you why that is. Okay? Things that we need to know. First off, log stands for the word logarithm. Okay, but mathematicians don't want to sit there and write the word logarithm all the time, and so they just abbreviate it as log. Okay? A log is really a way of rewriting an exponent. So right down here is basically your translation between the two. Okay? It's the translation between the two. So if we have, for example, if we have, let's say, 8 to the third power, take that back, 2 to the third power equals 8. That's what I wanted. 2 to the third power equals 8. Okay, that's written in exponent form, right? And we all know that that's true. Well, what a log does, remember I said a log is an exponent. A log allows us to solve for exponents. Okay? That's what it allows us to do, to solve for exponents. So, for example, logs allow us to ask the question, how many 2's do I multiply to get 8? Or 2 to the x power equals 8. Okay? So that's what a log allows us to do. And so in rewriting this, notice the color coding in that little thing I have up in the rectangle there. Okay, rewriting this as a log. All right, first off, I said a log is the exponent. Now, in translating math to English, the word is means what? Equals. Yeah, is just an equal sign. And so the log is the exponent. Well, what's the exponent here? 3. So therefore, our log is going to equal 3, because the log is the exponent. Okay? So it equals 3. Well, next, logarithms, just like exponents can have different bases, right? Right now the base is 2, the exponent is 3, right? Well, it doesn't say that all bases have to be 2, right? I can have a base of 3, a base of 5, a base of 40, right? I can have any number raised to an exponent, so the base can be any number. So same thing with logarithms. The base of a logarithm can change. In this case, it's base 2 because the base over here is 2. We call this log base 2. We use the same language for logs as we do for exponents. In the exponent, the 2 is called the base. Well, therefore, in the log, the 2 goes down here. That's called the base. So we have log base 2. And then it's log base 2 of, in this case, 8. Log base 2 of 8 equals 3. This right here is simply asking the question, how many 2's do I multiply to get 8? Okay, that's what log base 2 is essentially asking. How many 2's do I multiply to get 8? Okay, and we can rewrite that as an exponent. 2 to the third power equals 8. Okay? Being able to do that is the biggest challenge for today and actually for the next week. Okay? We're going to be quizzing over this stuff next Thursday. So make sure you guys are aware on that. We're starting our next, quizzing cycle. Today's our first lesson. Okay? The quiz over this stuff will be next Thursday. So, you've got to be able to switch back and forth from log notation to exponent notation. Okay? That is going to be the big thing to know today. How do you go back and forth between the two? And one thing that will help you is knowing first off that the language is the same. The base of a log is the same as the base in an exponent, an exponential form. Also remember that the log is the exponent. So that means log whatever is going to equal the exponent. Okay, so in this case we have base 2, exponent is 3. So therefore log base 2 is going to equal 3. Log base 2 of 8 equals 3. Any questions so far on just what a log is or the rewriting between the two forms? So let's take a look at a first couple examples here. Example A, what is the logarithmic form of each equation? So we'll do A together. I want you guys to do B and C on your own. So first off, in A, if we're rewriting this as a log, okay, remember, log is going to equal exponent, because the log is the exponent, right? So therefore, log whatever is going to equal what? 2, because that's the exponent. All right, well, what's the base in exponential form? 10. So then our base for log form is also 10. All right, so log base 10 of what is going to equal 2? Log base 10 of 100 will equal 2. That's it. Yep, rewriting from exponential form to logarithmic form. That is it. Okay? We're not going to work with calculators yet. We'll get there. We can do this with the calculator, but we're not going to do that yet. Okay? What I want you guys to do if you want to check it or test if you're right, anything like that, is basically you're going to go back to exponential form. You're going to say 10 to the second power equals 100. And you're going to use your calculator to say, well, is that really true? Does 10 squared actually equal 100? Which, of course, it does. Okay? But yeah, we're going to hold off on the calculator work for just now. Because remember I told you guys before that some of this quiz and some of this test is going to be no calculator. Well, this is one of those no calculator parts. Okay? All right, any questions on rewriting to logarithmic form? And let's see what you guys can do on your own here. So I'd like you to do B and C. B and C. All right, so for example B here, what do we have? Log base what? Log base 3 of 81 equals 4. Excellent, perfect. That's exactly what we do. Log base 3 of 81 equals 4. By the way, that's how we say that. You know, you guys like to make up a lot of ways of how you say these things. There's a specific way of how we say this. That is read log base 3 of 81. Okay, and so please make sure you're reading it properly. Okay, log base 3 of 81. All right, how about for part C?
Log base 3 of 1.
Log base 3 of 1 equals 0. Perfect. And by the way, we all know that 3 to the 0 power equals 1, right? Yeah, perfect. What's 5 to the 0 power? 1. What's the square root of 3 to the 0 power? 1. What's 5 billion to the 0 power?
1.
You guys get the idea here, right? Anything to the 0 power other than 0 is going to equal 1. So when you're going through and you're taking the logarithm of any base, log base anything of 1, it should always equal 0. Okay? Because they're basically asking 3 to what power equals 1. Well, that would be 0, right? Or they could be asking, like I said, they could be any base there, log base 1/8. Well, 1/8 to what power equals 1? 0. Okay, so if you're taking the log of any base of 1, your answer is always going to be 0. Okay? All right. So let's do one more of the rewriting right here, because, man, we got fractions involved now. Uh-oh, does that change anything? No. Not a thing. Not a thing. So we have then log base what? Base 2/3 of 8/27 equals 3. Excellent. Okay? Everybody good? All right. You've got to know how to rewrite. You've got to be able to go back and forth from log notation to exponent notation. That is a key thing. If you can't do that, this whole week is going to be, well, it's going to be extremely difficult because this is the core of everything we're doing for the next week. Okay? You've got to know how to do this. You've got to know how to go back and forth between log notation and exponent notation. All right, so let's see how we'd go about evaluating logarithms. Okay? So what they want us to do here is they want us to evaluate log base 8 of 32. Okay? Log base 8 of 32. So, log base 8 of 32, what you're going to do is you're literally going to write a little equation and just say log base 8 of 32 equals x. We're solving for x. We want to know what this evaluates, or what this equals. Okay? So, the way we're going to do this first is by rewriting it. How do I rewrite that in exponential form?
32 equals 8x.
8 to the x power. That's probably what you meant, but 8 to the x power equals 32. Okay? 8 to the x power equals 32. So, remember, we're looking for that exponent. We're solving for x. Now, in previous sections, the only way we knew how to solve for an exponent was to use a calculator. Okay? Right? And we just plugged in numbers and tried stuff. Well, we're getting away from that. We're going to learn a process for solving for exponents that doesn't necessarily need a calculator. This is one of those times. So first thing, question, if this said 8 to the x power equals 64, what's your answer? X has to equal 2, right? X would have to equal 2. What if I went through and rewrote this? 64 can be rewritten as 8 squared, right? Okay. Well, then do you guys notice that if the bases are the same, the exponents must be equal? Because again, you already told me that x has to equal 2, right? And so therefore you guys see that here x must equal 2. Exponents have to be equal, correct? Does that make sense? Okay. Well, what we want to do here then, notice first off, there is no whole number exponent that we can raise 8 to get 32. Right? So therefore, our exponent must be some kind of fraction. So to find that fraction, what we want to do is we want to rewrite 8 and rewrite 32 using exponents, and so that they have the same base so that we can set our exponents equal to each other. So first off, how would I rewrite the number 8 using exponents? 2 to the third power. Yep. So 2 to the third power raised to the x power. Okay, and then 32 is 2 to the fifth power. By the way, that roots chart that you guys should still have, it's handy to have right now if you don't know these things. It's nice to have. Okay, well, 2 to the third power raised to the x power. What do we do when we take a power and raise it to a power? Multiply them. So we have 2 to the 3x power. equals 2 to the 5th power. I'm going to bring my work over here. So now we have the same base, so then our exponents must be equal. So therefore 3x must equal 5. So then to solve by 5, we divide by 3. Or, I'm sorry, to solve for x, we divide by 3. So x equals 5/3. So therefore, we can write our answer log base 8 of 32 equals 5/3. Log base 8 of 32 equals 5/3. Now, a way to check your answer involves your calculator. If you want to check to say, well, did I do that right? Grab your calculator. You're going to want to go through and basically rewrite this in exponential form. 8 to the 5/3 power should equal 32. And so I would type it into my calculator like this. 8 raised to the 5/3 power. Okay, those of you typing into your calculator, is everybody getting 32? Perfect. All right, questions on that process? Let's take a look at another example. Log base 5 of 125. Okay. Again, to evaluate this, you just make it into a little equation. You say, okay, we're solving for x. We have to rewrite it. 5 to the x power equals 125. Now, many of you already know the answer looking at that, okay? And I get that. But let's practice the process. So, can I break down 5? Can I rewrite 5 using exponents? Just 5 to the first. That really doesn't help us, right? 5 is already broken down as far as it can go. Well, can I rewrite 125? Where 5, I have to have 5 as my base now. Can I do that? Yeah, I can. Yeah, I can. So I have 5 to the x equals 5 to the third, which means x must equal 3. So we now know that log base 5 of 125 equals 3. Log base 4 of 32. We want to evaluate that. Well, again, your first thing is set it equal to x, because that's what we're solving for, right? And so now what? Who can tell me? Four to the x equals 32. So I rewrote it using exponents. Now what? Okay, so 4 can be broke down or rewritten as 2 to the 2nd power raised to the x power. How about 32? 2 to the 5th power is 32. So what do I do when I have a power raised to a power? I multiply them. So I have 2 to the 2x power equals 2 to the 5th power. And so now I have my same bases. So now I can say that the exponents have to be equal. So then 2x must equal 5. Dividing both sides by 2, x equals 5 halves. So our answer is log base 4 of 32 equals 5 halves. All right, next problem. Again, first step is always to do what? Set it equal to x. Just make it into an equation. We're not just evaluating this, we're trying to solve for what x is, right? And the reason we do that is because now we can use that rule for logarithms. We can change it into an exponent by rewriting it as 64 to the x power equals 1/32. Okay, well, let's break down 64. What is the smallest base that I can rewrite 64 as? 2. Smallest base would be 2. 2 to what power?
64 is 6.
2 to the 6th power is 64. So 2 to the 6th power raised to the x power. So if I multiply those, I'm just going to have 2 to the 6x power, right? Okay, well, now we got to deal with 1/32. We want 1/32 to have a base of 2. We want it to be 2 raised to some power. How the heck am I going to do that? I can rewrite the fraction as 32 to the negative first power. Right? Everybody see that? Remember, negative exponents mean that this 32 wants to drop to the denominator. Okay, so I want to bring that 32 up to the numerator. I want to get rid of this fraction altogether. And so I've got 32 to the negative first power, which now I need to work with that 32. 32 can be rewritten as 2 raised to the what? 5th power raised to the negative first power. So we have 2 to the 6x equals 2 to the negative 5th. Now we can say 6x equals negative 5. And so therefore, what does x equal? Negative 5/6. So we can write our answer log base 64 of 1/32 equals negative 5/6.